Good morning. So today we are going to be focusing on solving radical inequalities. So what we're going to start with is solving a radical equation and keeping in mind that there are a couple things we need to remember with radical equations. One of them is that if I have the square root of anything, whatever is under here, it has to equal a positive number. So if I have the square root of something and the square root or the radical is all by itself on one side of the equal sign, if this number is negative, we have no solution. However, in this case, it is positive. The inverse operation to a radical or to a square root is squaring. So I'm going to square both sides. So I have x minus 6 equals 5 squared is 25. Need to get x alone. One thing you need to remember too is when you square this, right here, the square root sign and the square completely undo each other. What's left underneath that square root sign is untouched. So finish my thought over here. This was 25, so 5 squared is 25. Then I just need to get x alone. So I'm going to add 6 to both sides. So x equals 31. So that's solving a radical equation. An inequality is slightly different, and there's something else that you need to pay attention to. So we still have the same process. We square both sides, and we have x minus 6 is less than or equal to 25. Add 6. So we have x is less than or equal to 31. So I have a 0 here, got 31 way over here. I know my solution is going to have a closed circle. It needs to be less than 31. It would help if I actually wrote the correct boundary point, so 31. The problem with this is if I keep going out to infinity, I run into a problem. Because if I put, let's test 0. If I put 0 in for x, if the square root of 0 minus 6 is less than or equal to 5, I'm left with the square root of negative 6. And the square root of negative 6 is an imaginary number. This is not something that we can put in real terms as being less than or greater than 5. So what I have to do before I can go through all this part is to look at what is underneath my square root sign. So I have x plus 6, and I have to make sure that x plus 6 is greater than or equal to 0, because I cannot take the square root of a negative number. So I'm going to subtract 6. So I've got x is greater than or equal to negative 6. So that puts this boundary here, just kidding, negative 6. Oh, I screwed up back here. Figured it out. Okay, way back up here in my original, when I was doing it, that's why this came out so funky. Sorry for that confusion. This is negative. So that needs to be negative. I had written it as positive. So I'm going to add 6 to both sides. So x is greater than or equal to a positive 6. Anything less than 6 is going to make it so that I have a square root of a negative. So I also need to add that boundary point. And so if x has to be greater than or equal to positive 6, then my solution set is everything in between. So I have 6 is less than or equal to x, which is less than or equal to 31. So there has to be two parts to this. So one is figuring out what my restriction, and this is referred to as the domain restriction, what that restriction is on what's under the square root sign. So that adds one part to it. The next part is actual solving and finding my other parts. And in some cases, it's going to be necessary to check several different points to see what ways all my inequality signs should be facing. So we're going to take some notes on this. If you want the hard copy of this, just let me know. So key thing to remember, you can only take, I don't really want to write that in yellow, you can only take the square root of a positive number. So the first thing you need to do is find out what your limits on x are. So this part right here, under the square root, x plus 3 has to be greater than or equal to 0. So what that means is x has to be greater than or equal to 3. That is one part of my answer. Now I have to figure out the other parts. So my possible boundaries, I need to solve the inequality. So I have x plus 3, and I'm going to go ahead and just say equals 2. No, I can go ahead and do greater than, no. Square both sides, x plus 3 equals 4, minus 3, whoops, minus 3. So x plus 3, wow. So x equals 1. So that's gracious. So this is my these are my two boundaries. I've got 0, I'm going to put 2 spaces here, 1 and 3. I know from the 3, the x is greater than or equal to 3, that it has to be going that way. And from the 1, if I use my original greater than or equal to, I've got x is greater than or equal to 1. I want to double check that. If I put in 0, just to double check it, if I have the square root of 0 plus 3 is greater than or equal to 2, I've got square root of 3, which is between 1 and 2, which is not greater than or equal to 2. So that one doesn't work. So I already know that it can't go in this direction. So when I'm looking at my restriction and then my answer, what the solution, when I just have a number on one side, is this overlapping part. So then my solution is simply that x has to be greater than or equal to 3, and then my interval notation is the bracket with 3 out to infinity. On this one, I have x's on both sides. So that's going to create a bit of an issue. First, I need to find the limits on x. X plus 6 has to be greater than or equal to 0 because I can't take the square root of a negative number. Minus 6, so x has to be greater than or equal to negative 6. That is one part of my solutions. I'm going to go ahead and put that negative 6 down here. It's one part that I know. And then I want to find the boundaries. So I take my original x plus 6 is greater than x. I'm going to square both sides, and this is where it gets more complicated. That x plus 6 is greater than x squared. Now I have a quadratic that I need to deal with. So I'm going to subtract x, subtract 6. So I've got 0 is greater than x squared minus x minus 6. And now this is the same as in 5b-2, where I have to solve that inequality and check my boundaries. So I would solve this using factoring. I'm gonna do the quick and dirty and just factor it in my brain. So if that is a struggle for you, I would definitely go back to 5b-2 and 5a2. So this factors to x minus 3 times x plus 2. So I have boundaries at x equals 3 and x equals negative 2. So I'm going to put those boundaries on my number line. So that's 6, I got 0, a little closer. 5, 4, 3, 2, 0. I've got negative 2, and I've got 3. So now I have to think about my original inequality and what numbers work in there. I don't need to check this space over here because I already know x can't be anything less than -6. But I'm going to check something from here, and from here into my original. So my original equation was square root of x plus 6 is greater than x. So a number that I can pick from this little solution set here is -3. And none of these numbers are going to come out nicely. So square root of -3 plus 6 is greater than -3. So I get the square root of 3 is greater than -3. This is going to be a positive, so this is something like 1 point something. Is greater than -3. That is true. And I don't have a calculator on me, so I'm not going to try to estimate that decimal further. The next one that's going to be easy to do is in this middle section here is 0. So I'm going to use square root of 0 plus 6 is greater than 0. Square root of 6 is greater than 0. That is also true. Then for the last section, I'm going to use 5. So the square root of 5 plus 6 is greater than 5. Square root of 11. The square root of 11 is going to be somewhere between 2 and 3. No, just kidding. 3 and 4. So 3 point something is greater than 5, which is not true. So what I have here, assuming I've done everything correctly, is 2 solution regions that work. So basically, this told us that this section works, and this told us that this section works, but this section over here does not, and anything over here does not. So our overall solution region is going to be from -6 up to 3. I'm now looking at this again. These should be open circles. My apologies for that. Oh, actually, the -6 can be closed circle, and that's a little confusing. This 3 has to be open circle, because if I put in 3, I have 3 is greater than 0. Oh, wait, what am I thinking? No, my apologies. 3 would be greater than 3, which is not true. If it was greater than or equal to, it would be fine. But if I put -6 in, then I have 0 is greater than -6, which is true. So this one can be a closed circle. So my solution here is in, wow, my brain stopped working, sorry. In interval form, -6 to 3 with bracket and parentheses. And then in inequality form, x is greater than or equal to -6 and less than 3. So that is it for my part for 5b-3. This last one was a little confusing and I didn't help much of it, so if this video goes on longer, it's because I came back later and decided that we needed another example. So have a good one.